Hello friends, in last few videos we have seen the development of Schrodinger's equations. So Schrodinger's time dependent equation, Schrodinger's time independent equation, then concept of wave function, then de Broglie theorem, its physical significance, its experimental evidences, then concept of probability, then a probability density, equation of continuity and its physical significance, then formalism for Schrodinger's equations and its derivation. So there are the two types of the Schrodinger's equation. One is the steady state equation, that is the time independent equation, and another is the time dependent equation, which can be solved for a different problems. Now in next few videos we are going to see these applications of Schrodinger's time independent equation, that is the steady state. What is the steady state equation? So that is given by this steady state which is independent of time. And how this independent Schrodinger's equation is used to solve the different problems in physics. Say which are the properties related to the steady state equations, and this a simple problem is a free particle problem. So free particle problem can be solved using the Schrodinger's steady state equation. So there is another problem in many cases came. So that is the particle in infinitely depth potential valve. So potential valve, we know that potential valve, but the depth of that potential valve is infinite. So infinitely depth potential valve, and if the particle inside the potential valve, how that behaves and what are the outcomes from that problem. And another one is particle in a rigid box problem. So any box is there and say particle is inside the rigid box, then how we calculate its parameters, its energy, its momentum, and so on. Next one is the step potential. So this potential is there, but there is a step for that potential. How we solve using this one. Another is a potential barrier. This potential barrier concept is the very important in the physics, and how that a classically potential barrier, how we overcome, quantum mechanically how we overcome this potential barrier, and how that mathematical expressions can be attained. And last one is harmonic oscillator. So harmonic oscillator is one of the problem in physics, in chemistry, even in biology also. So one oscillator, harmonic oscillator for the one dimensional. Then we go for the three-dimensional later on. But in this chapter, we will see these 6 points. That is, one is the free particle problem. Second one is the particle in infinitely depth potential valve. Third one is the particle in rigid box. Then fourth one is a step potential. Then particle potential barrier is the fifth one. And sixth one is a one-dimensional harmonic oscillator. Okay, so this sixth one is a one-dimensional harmonic oscillator. So these problems are for our examination point of view, and we are going to see how to solve these problems using the Schrodinger's steady state equation. Okay, so be careful, go through all these videos and watch them repeatedly, and try to understand for the examination point of view. Thank you.